CP1-2 is all about classifying both triangles and some special quadrilaterals. So a right triangle has exactly one right angle. An acute triangle has three acute angles, so all their angles are less than 90 degrees. And then an obtuse angle has exactly one obtuse angle. When you're sorting these out, remember your acute angle should have all angles that are less than 90. Your right triangle has one right angle marked with the little 90-degree square in the corner. And your obtuse triangle has exactly one obtuse angle. Okay, so a scalene triangle has three distinct side measures. Meaning all three sides are a different length. So you could mark that in your triangle by showing that all three have different measures. None are the same. Isosceles triangle has at least two congruent sides. That at least means that there could be three, but there has to be two. And then an equilateral triangle has exactly three congruent sides. All right, when I'm sketching this, I'm gonna do this one step at a time. So I'm asked to sketch an acute scalene triangle named PQR. So I'm gonna make all the angles less than 90 degrees, and I'm gonna make each side length different length. And then I'm naming it PQR. And then it says there's an angle bisector QT. So from Q, I'm going to add in my angle bisector. I'm going to show it's an angle bisector by marking each half of the angle the same, and then I'm adding that point T so that it's named QT. All right, my second example asks me to sketch a right isosceles triangle named ABC. I'm going to start with that right angle, and I'm going to make my side lengths equal. And I'm going to mark that it's a 90-degree angle, and then I'm naming it ABC. All right, Susie says she drew a right equilateral triangle. Susie's wrong, though, because you can't have an equilateral triangle with 90 degrees. Okay, an equilateral triangle, since all the sides are the same, all the angles end up being the same. So they each are 60 degrees. If it was a right triangle, all of math will fall apart. All right, a trapezoid has one pair opposite sides parallel. And this might be different than what you learned in elementary school, and that's okay. Our textbook teaches it as exactly one pair. So sometimes kids are like, well, parallelograms are within trapezoids and are like a special type of trapezoid. Not quite. Okay, trapezoids are their own thing. A kite has two pairs consecutive congruent sides. And what that means is the ones right one after another are congruent. Your parallelogram then has two pairs of opposite congruent sides, or parallel sides rather. Your rhombus has four congruent sides and two pairs opposite parallel sides. So not only are they parallel going across, but they're all congruent as well. A rectangle has two pairs opposite congruent sides. They're also parallel and has four right angles. So all of my angles are 90 degrees, and those are the same, and these are the same. A square then is kind of like a rhombus and a rectangle put together. So you've got four right angles, and you have all sides congruent. That was a lot. So all of these things fall under quadrilaterals. Okay. Within quadrilaterals, we've got kites. That's the one that has two sets of sides that are congruent to each other, one after another. You've got trapezoids, which have the parallel lines, or two parallel lines. And then you've got all these parallelograms. And to be a parallelogram, you just have to have two sets of parallel sides. So parallelograms have that, rhombi have that, squares have that, rectangles have that. Within parallelograms, rhombi exist, where, hey, they're parallel and the sides are congruent. Rectangles exist, where, gee, they're parallel and all the angles are 90 degrees. And then you've got squares, which are parallelograms and rhombuses and rectangles, because the sides are parallel, the sides are congruent, and the angles are all 90 degrees.